Just like we looked at the crossed aldol condensation, there's also a crossed Claisen condensation. So the first case we're going to deal with is when we're going to look at two different esters. Okay, so when one of them is going to get deprotonated to be the nucleophile, and then the other one's going to be the electrophile. And the only way this reaction will work well is if we use preformed enolates. But preformed enolates, as we shall see, will also allow us to use ketone enolates as nucleophiles in a Claisen condensation. Okay, so let's deal with case 1 first. And the first reaction that we have to do is to preform the enolate. So we're going to take a simple ester here, ethyl acetate, deprotonate it with LDA, deprotonate the hydrogens from the alpha carbon, and that's going to generate the enolate as the nucleophile. And of course, LDA is a strong enough base that formation of this enolate will happen completely and irreversibly. In the second reaction, we will now take a different ester, so this one with a cyclopentyl group sticking off of it, add it to the enolate that we generated in reaction 1, and the new ester that we're adding serves as the electrophile. They're going to undergo the reaction. I'm not going to give the whole mechanism here because we've already looked at that mechanism in detail, but the final product that you're going to get is the beta keto ester. Note that this is after deprotonation and reprotonation. So as you should recall, the driving force for the Claisen condensation is the removal of that very acidic hydrogen between the two carbonyls of your 1,3-dicarbonyl product. And then that, in order to get a neutral product, we have to put that hydrogen back on in the acidic workup step. Also note that it is the electrophilic ester, the one that is added second to the enolate, that becomes the ketone in the final product. Okay, now let's look at case 2. In this case, we're using a ketone enolate, so we're going to start with acetone, our simplest ketone, deprotonate it using LDA to make the enolate of acetone, and then we're going to add the second ester. So once again, the same ester that we used in the previous example, but now instead of getting a beta keto ester, we are now going to get a beta diketone. And once again, I don't have it written over the arrow, but we're going to have to do an acidic workup here because deprotonation is going to happen spontaneously under the basic conditions of this reaction, and then reprotonation will have to happen again to give a neutral product. Okay, now there is still a case 3 for this reaction. I know I only put 2 cases on the previous slide, but there is a case 3. And it is possible to carry out a crossed Claisen condensation with sodium ethoxide as the base instead of using LDA if one of the esters does not have any alpha hydrogens and therefore must be the electrophile. Okay, so an example of this reaction is if we take ethyl benzoate here, which has no alpha hydrogens because of the aromatic ring, and react it with ethyl acetate in the presence of sodium ethoxide. So the ethyl benzoate cannot be deprotonated, only the ethyl acetate will get deprotonated, and the enolate that you generate out of ethyl acetate is then going to add to the carbonyl of ethyl benzoate to give the beta keto ester product that is shown. Now do note in this reaction that the self-condensation of ethyl acetate to give ethyl acetoacetate will be a second product in this case. We cannot suppress that reaction, but at the same time, if we only have 2 products, it actually is a separable mixture, and this reaction can be useful under these conditions. However, there's no real problem with doing these reactions using LDA as the base and preformed enolates. So that's probably the best bet if you're trying to do one of these crossed Claisen condensations. Okay, so that brings us to the end of our discussion on the Claisen condensation. We talked about the simple reaction, the intramolecular version, and the crossed version. Just like we did for the aldol, there is no dehydration to have to contend with for the Claisen condensation. But the product of Claisen condensations are 1,3-dicarbonyls, and in the next video, we're going to look at another important reaction of 1,3-dicarbonyl compounds.